All right, so number 21, we're going to start off by graphing the system. As we saw earlier, we're going to start with y equals 4. First of all, since the slope is 0, we're going to have a horizontal line. Just need to make sure that it goes through 4. 1, 2, 3, 4. Have a y-intercept of 4, and we ended up with a horizontal line. So that's the graph of y equals 4. Next thing we're going to do is we're going to graph the next equation, this one right here. -2, that's going to be our y-intercept. That's going to be right here. The slope is going to be 6, or 6 over 1. So we're going to rise 6, run 1. We can also go down 6. 1, 2, 3, 4, 5, 6. And left 1. Connect the dots. Now, as I mentioned earlier, if you leave it like this, that would be incorrect, because what I'm looking for is the point of intersection. Where do they cross? In this case, they cross at the order pair 1, 4. So I'm going to be looking for the order pair, not necessarily at the graph itself. That's what I'm grading, those points. All right, so there's our answer to number 21. Order pair 1, 4. All right, let's try that again with number 22. It's the same thing. We're going to start off by graphing this equation first. So +3, that's going to be our y-intercept. That's where we're starting at. What's the slope on this one? -1 over 1, which is telling me to do what? Down 1 to the right 1. Down 1 to the right 1. And the more points we have, the more accurate our line will be. So get as many points on there as possible. Matter of fact, you can go the other direction, going up 1 and left 1. Again, the more dots we have, the straighter the line. All right, so once I connect the dots, this is the line that I get. Then what we'll do is we'll take that other equation and graph it as well. So let's graph this one now. This time the y-intercept is going to be at -3, which would be right here. The slope on this one is 5. 4, 5 over 1. So I'm going to rise 5, then run 1. 1, 2, 3, 4, 5. Run 1. 1, 2, 3, 4, 5. Run 1. I can even do the opposite, go down 1, 2, 3, 4, 5, and left 1. Connect all those dots. And then all that's left for me to do is find where they intersect. All right, so that's this point right here. And what is that intersection point? 2, 1, are you sure? 1, 2. All right, so 1, 2 would be our solution. The points of intersection. All right, the next couple here, same thing, except this time they didn't give us the equation in slope-intercept form. We have to convert it. So I'm going to take that one and write it in slope-intercept form, which in this particular case shouldn't be too difficult. All it requires me to do is move the x to the other side. And when I move that x to the other side, it goes from being a positive x to a negative x. So this is what I'm going to be graphing for that first equation. So 4. 1, 2, 3, 4. That's going to be my y-intercepts. The slope on this one is -1. So it's just like the last example. We're going to go down 1 and to the right. Down 1 to the right. More dots I have, the straighter the line is. I'll get more points on this side by going up 1 and left 1. Up 1 and left 1. Connect the dots. And we got our first line. Second line. What kind of line did we say we were going to have on this one? What kind of line?
We are not speaking.
Yes, you are. What kind of line do we have? We saw it on number 1, I think it was. Horizontal. This one has to go through 3. Okay, so 1, 2, 3 would be right here. So all I'm doing is drawing me a horizontal line through 3. Of course, to find the answer, I've got to find where they intersect at. And they're going to intersect at that point right there. What is that point? What is that order pair? 1, 3 is correct. 1, 3. So my solution at number 23 is going to be the order pair 1, 3. All right, let's try number 24. It's going to be the same thing. For this first equation, I'm going to have to write it in slope-intercept form. So I'll start by moving the x to the other side, which is going to make it a -2x. but there's still a negative 3 in front of that y, which means I'm going to have to come over here and divide everything by negative 3. That way I can have y by itself. And a negative 2 divided by negative 3 gives us a positive 2/3. And a negative 9 divided by negative 3 would give us a what? Positive 3. So here's my new equation. That's what I'm going to be graphing. So I'm going to come over here and start at 3. That's the y-intercept. 2/3, that's going to be my slope. Up 2, run 3. Up 2, run 3. Up 2, run 3. And do that the other way as well. Go down 2, run 3 backwards. Down 2, run 3 backwards. So on and so on. All right, so we'll connect these dots. And we got our first line. Now we need to do the second line. Now we need to take this equation and do the same thing. We need to get it in slope-intercept form. All right, so let me make some room here. Let's show our work for that second equation. So here we have 4x plus 3y equals negative 9. Just like I did with the first one, we're going to start by moving the x to the other side, which makes it a negative 4x. Now I'm going to divide by 3. And a negative 4 divided by 3 would be a negative 4/3. And a negative 9 divided by 3 would be a negative 3. So here's our new equation. That's what we're going to be graphing. All right, so negative 3. That's where we're starting at. That's going to be down here. Negative 3. Negative 4/3 is our slope, which means we're going to go down 4. 1, 2, 3, 4, and to the right 3. I can even go up 1, 2, 3, 4, and then 3 to the left. 1, 2, 3, 4, 3 to the left. Okay, so I'm going to go ahead and connect these dots. There's that second line. And what I want to do is find that point of intersection. That point right there. That order pair is what? Negative 3, positive 1. So there's our answer to number 24. All right, so that's the graphing method. The next couple you have here, number 25 and number 26, they're asking you to use the elimination method. And when I grade this, guys, I am going to be looking to make sure you're using the correct method. If you don't use the correct method, you don't get credit, even if it's the right answer. All right, so the elimination method means I've got to eliminate either an x or a y. And right now, the way it's written, nothing's going to count. Nothing's going to eliminate. So what I'm going to have to do first is take this top equation and multiply it with some number. Anybody know what number I'm going to multiply it with? 2. I'm going to take that top equation, multiply it with a 2. So 2 times 3x would be a 6x. 2 times 7y would be a 14y. And 2 times a negative 20, that's going to be a negative 40. So all I do is take the top equation, multiply it with 2. Second equation, I'm going to leave it just like it is. And hopefully you can see now why I multiplied that top one by 2. Because now I can eliminate these x's with a little subtraction here. So I'm going to subtract my 2 equations. 6x, you take away 6x, now you have no more x's, they're all gone. We've got 14y's, we're going to take away negative 1. So 14 minus a negative 1 would be 15y. And negative 40 minus a negative 10. What's a negative 40 minus a negative 10? Negative what? 30. Negative 30. And since I'm solving for y, I'm going to come over here and divide by 15. And negative 30 divided by 15 would leave me with a negative 2. Okay, so negative 2 is my y value. Of course, I'm not done yet. I still got to figure out what x is. So what I'm going to do is I'm going to take that negative 2, and I'm going to plug it either for this y or for this y. It really doesn't matter. It's your choice. You want to use the top or the bottom? Bottom. All right, so we use the bottom. So all I'm going to do is take out that y and replace it with a negative 2. So it now looks like this. Now, I don't like those two negatives. That minus and that negative is going to make this a plus 2. So I don't have so many negatives. Solving for x, so I'm going to come over here and subtract the 2. Negative 10 minus 2, that's a negative 12. Finish it up by dividing by 6. And a negative 12 divided by 6 is negative 2. So now we're going to finish it up by writing it as an ordered pair. When you write that ordered pair, remember the x comes first, so that's negative 2. And then the y comes last, negative 2. So there's our ordered pair. That's number 25. So for number 26, we're going to turn around and do the same thing. Right now, I can't eliminate anything, so what I'm going to do this time is I'm going to multiply this bottom equation by something. Question is, what are we going to multiply the bottom one with? Which one? 2. We're going to use the 2. 2 times 6x would be a 12x. 2 times 5y is going to be a 10y. And 2 times 12 is 24. I'm not going to touch the top equation. It's going to stay the way it is. And the reason I multiply that bottom equation by 2 is so that I can come over here and use a little subtraction so that I can get rid of those x's. 12 x's, you take away 12 x's, now you have no more x's. What do you get when you subtract over here? Negative 7y minus 10y. Negative 7 minus 10. Joseph, what's a negative 7 minus 10? No. Negative what? Negative 17. Use that calculator. 24 minus the 24. 24 minus the 24 is 0. Now, some of you stop right there and say, oh, 0, no solution. Oh, that's not true, guys. We need to finish it up. Come over here and divide by negative 17. And 0 divided by negative 17 is 0. We're not done. That's only the y value. Still got to come over here and figure out what x is. So we're going to take that 0 we found, and we're either going to put it here or here for one of these y's. It really doesn't matter. I think I'll use that bottom one. So I'm going to take out the y, replace it with a 0. And let's see what we get here. 5 times 0. 5 times 0 is 0. That's gone. So I've got 6x equals 12. So I'll come over here and divide by 6. 12 divided by 6 leaves me with 2. So now we got both the x and the y. We can write our ordered pair. And that ordered pair should be 2 zeros. And there we have our answer, number 20. All right, for number 27, this time instead of using the elimination method, this time they want me to use the substitution method. Now notice there's only one of those, and that's because this one does take a little more work. So what I'm going to do is I'm going to take that first equation, and I'm going to get one of the letters by itself. And what I'm going to do is I'm going to get the x by itself. And that's because all I need to do is move the y to the other side. And we're going to do that by adding. So this right here, I'm calling it my first step. I got a letter by itself. What I'm going to do now is I'm going to go to that other equation, and I'm going to replace this x with all of this stuff right here, with a negative 7 plus y. Of course, the rest of the equation is going to stay like it is. Notice the only variable I have now is the y, and I'm going to solve for that y. 3 times negative 7, that's a negative what? Negative 21. 3 times y, that's 3y. Keep the minus 3y. Keep the negative 8. All right, notice we have some like terms. I'm going to combine these right here. So 3y minus the 3y. What's a 3y minus a 3y? 0. So notice there are no more y's. All of these y's have canceled each other out. And what I'm left with is this right here. I'm left with a negative 21 on the left, and I'm left with a negative 8 on the right. But notice there is no y. What is that telling me? It's telling me that there is no solution to this. Anytime we have no variable and a false statement like we have here, that's a no solution. Now tomorrow on the test, I may decide instead of a no solution, it may be an infinite solution. What would that look like?
A sideways 8.
Well, yes, you're right, this would be a side, but what I'm saying is, what would it look like in the problem? It would be a true statement. It may be something like -8 equals -8. So if it's true, then it's infinite. If it's false, then it's no solution. Yes.
Tomorrow, like when we take it, is it going to be, like, are we going to have one section for elimination, one for substitution, or are you just making us problems like that?
No, it'll say, just like it says here, it'll tell you what method to use. Now, on the next two, 28 and 29, notice it doesn't say what method to use. So on those two, you can use any method you want. So on number 28, it says here that the school that Kayla goes to is selling some tickets for the annual dance competition. On the first day, the tickets sold 9 adult tickets and 5 child tickets for $145. The next day, they made $130 by selling 2 adult tickets and 10 child tickets. We're looking for the price of 1 adult and 1 child ticket. So we're looking for the cost of 1 adult ticket, and I'm going to use A for adult ticket. And I'm also looking for the cost of 1 child ticket, and I'll use the letter C for child. All right, so let's take the first day. We sold 9 adult tickets, so there's 9A. We also sold 5 child tickets, so that would be 5C. And the total amount of money we raised was $145. So there's the first equation. The next one here, we had 2 adult tickets, 10 child tickets, and that day we raised $130. So this is our system. Now at this point, you can use any method you want. Now there was a method I showed you guys on the calculator called matrix. Y'all remember that one?
Yeah.
Let's try that one on this one here. Let's go to our calculator, and let's go to matrix. Everybody go to matrix. And that's going to be in blue, matrix. Then we went to edit. And this particular one is going to be a 2 by 3, and that's because we need 2 rows with 3 columns. And in that first row, we're going to type in these 3 numbers right here, the 9, the 5, and the 145. In the next row, we'll type in the 6, not 6, but the 2, the 10, and the 130. We'll clear our screen. Anybody remember what we did after we got it in there? Go back to matrix, but instead of going to edit, this time we go to math. And under math, what we're looking for is the one that says RREF. That's the one we're looking for, RREF. You're going to select that one. And then it needs to know where you put your number. So go back to matrix one more time. You're going to select matrix A, because that's where we put the numbers in. And then you're going to hit enter. And you're going to see something that looks like this right here appear on your calculator. So what does that mean for us? That's right. These 2 numbers right here represent our solution. So that 10, the 10 is what? The adult or the child tickets? The adult. So for 1 adult, it's going to cost $10. 1 child, $11. That's what those 2 values are, 10 and 11. All right, because we're a little short on time, guys, I'm going to go ahead and skip the next one. You would do it the same way, number 29. Let's go ahead and go to the last section of this. Skip 29. Let's go to number 30 real quick here. For number 30, we're going to graph this system of inequalities. 2 is our y-intercept. -3 is our slope, meaning we're going to go down 3 and over 1. Down 3 over 1, down 3 over 1, down 3 over 1. We can also go up 3 over 1. Now be careful because before you connect those dots, some of these are going to be dotted, some of them are going to be solid lines. This one is going to be a dotted, that's because there's no equal sign. And we're also going to shade below the graph. It says less than, so we should be shading below. This would be the bottom. There's our first inequality. Now I'll graph this inequality. -3, that's going to be right here. 2, that's our slope, meaning we're going to go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. We can even go down to left. Down to left. It says equal. Equal means we need a solid line. And greater than, we should be shading to the top. This would be the top of the line. Here's what our graph should look like. That's the graph of number 30. All right, next section, very easy. All they're asking us to do is name the polynomial. So for example, number 31 here, that's either a monomial, binomial, trinomial, or polynomial. This particular one is what? Monomial. Monomial because there's only one. Monomial. Number 32. What is that one? That's also a monomial. It's only one term. 33. Monomial. Number 34 has 1, 2, 3 terms, so that would be a trinomial. Now number 35, we're going to be subtracting these two, and we know that because it says minus right there. So what I'm going to do is I'm going to subtract this one minus this one. Those are the like terms. They both have p. So 5p, you take away 3p, that leaves you with 2p. We also have -4. We're going to subtract that with 6. So -4 minus 6 would be -10. And then this minus this, p to the 4. -8 minus 2 should be negative what? -10p to the 4. Now keep in mind, you may not find it exactly in that order. So which one of those choices has the same thing I have? Which one? D. All right, so D would be the same thing as what I have here. Of course, we would do the same thing with number 36. Again, we're subtracting, so I'm looking at this one, and I'm going to subtract this one. So we got 8 minus a -2. 8 minus a -2 would be, what's 8 minus a -2? No, not negative. A positive 10. So that's the x squares. Now I'm looking at x to the 4th, this one here, and this one here. We're going to subtract those. -1 minus a -2. -1 minus a -2 is +1. All right, next thing I'm looking at is this x and this x. 5 x's, you take away 4 x's, that leaves you with 1x. Okay, so that's the one I'm looking for. Again, it may not necessarily be in that order, but there should be one that means the same thing. And which one would that one be? B. B. B is the same thing as what I have here. Okay, number 37 and 38, we're going to be multiplying these together. 5 times 7x, that's going to give us a 35x. Then we'll multiply 5 with the 7, and 5 times 7 is 35. And that's it. We can't add those together because they are different. 38, we do the same thing. 4r squared times 7r, that's going to be a, hold on guys, hold on. Let me finish this up here. 4r squared plus 7r is 28 what? R to the third. Have a seat, have a seat. Nobody else get up. 4r squared plus 3 should be a
12R.
12r squared. That's the one we're looking. Alright, let's go ahead and do one last one. Let's do number 39. For number 39, we're going to have to use something called FOIL, which is just distributive property twice. We're going to multiply 8p times 3p, which is a 24p squared. 8p times 7. What's 8p times 7? 56 what? P. Then we're going to go inside here. 4 times 3p, that's going to be a 12p. And then one more, 4 times 7. 4 times 7, that's 28. However, most of the time, these two right here in the middle, you can combine those. When you combine those two in the middle, and when you combine those 56 and 12, you end up with a 68p. And that's what we're looking for. Alright, so again, the first half of your test will be tomorrow. That'll be 1 through 20. The second part will be on Thursday.